Hi guys, it's Miss Ruiz. In today's video, we're going to learn about integer exponents and the exponent properties. So please make sure you title your next available page in your notebook and write today's date. Remember that when you're taking notes, when you're writing and copying down the notes, the video should be paused, and make sure you're listening as I explain all of the notes. I will be going through your notebooks and checking to make sure that you have all of the examples done and all of the notes written down. So let's get started. Okay, so today's essential question is how can we develop and use the property of integer exponents? In this video, I'm going to introduce you to the property of integer exponents. In class, we'll do an activity to help you see how they're developed. So first, before we get started, we need to make sure that we understand what an exponent is. I know we've used them in previous lessons, but it's important that you understand what makes up an exponent. So here I have 3 to the 4th power, 3 to the power of 4. So one of these is the exponent, and that would be the small number that we see written to the right of the larger number is our exponent. Okay, so the 4 is the exponent, and the large number, we call that the base. Okay, so the base is the 3. It's the larger number. The exponent is the 4. Now, so what does this mean? This means that the base of 3, we're going to see it multiplied, and we should see it 4 times. So an exponent is not that we're multiplying 3 times 4. It's telling us how many times I should be multiplying the base. So here's an example here. 3 to the 4th would be 3 times 3 times 3 times 3. And if you look, that is the 3 is written 4 times. So this is what we call expanded form. When we expand out the exponent, we're showing how many times the base is being multiplied. And so to solve this, you're going to just do the multiplications for them. So I start with the first two. We have 3 times 3, and that's going to equal 9. And the second group is 3 times 3. That's going to equal 9. Now multiply 9 times 9, and that should give us an 81. So the answer to 3 to the 4th power is 81. Okay, so in this lesson, there are some vocabulary words that is important and it will be helpful for you to know. So let's talk about these. So the first one you're going to see is you're going to be asked to show things in exponential form. So think about it. The word exponential, we see that the word exponent, it has the root of exponent in here. And so it means just to write it as an exponent, with an exponent. Exponential form, we should see an exponent in that form of the answer. So when you're asked for exponential form, you're going to write the number as a base and an exponent. So in the first example, we have the one we used up top, 3 to the 4th, or 3 to the power of 4. The second one I have here is 2 to the power of 3. We also call this 2 cubed. We've already worked with that. Okay, so when we see an exponent of 3, we say cubed, or you can say to the power of 3. And then on this last one here, I have 5 cubed. Okay, so exponential form, you need to know what that means when you see it. Exponential form means you write it using an exponent. The next one is expanded form. Whoops, we need to. So in expanded form, so think about what the word expanded means. To expand means to stretch out. So instead of writing it as an exponent with 3 to the 4th power, I would expand that out so I can see what the base is that's being multiplied. So I'm expanding out the 3 times 3 times 3 times 3. So when you're asked to show something or to write something in expanded form, think about stretching that out so you can see everything that we are multiplying. So for 3 to the 4th power would be 3 times 3 times 3 times 3. 2 cubed, we should see the base 2 3 times, so 2 times 2 times 2. And 5 cubed, I should see the base 3 times 5 times 5 times 5. So that is expanded form, okay, where we're expanding it out. And then the last one is standard form. And standard form, standard is just probably uh, the best way to think of standard is something that is common, the most common. And if you think about your school life, since you were little kids, you probably haven't seen numbers written in exponential form, and you probably haven't seen numbers written in expanded form. But standard form is just basically the solution or the answer. It's one number. So 81. So instead of writing 3 to the fourth or 3 times 3 times 3 times 3, the standard form would just be 81. For this one, it would be 8. And for this one, 5 times 5 times 5 is 125. So please make sure that you have written this down in your notebook and that you come back and review if you're not sure, or rewind what the difference is between exponential form, expanded form, and standard form. This will be the language we'll be using in class, and you're going to want to know what that means. All right, so now that we've talked about exponents and what they are, let's go and start learning about the different properties and rules that apply when we're working with different kinds of exponents. So the first one we're going to talk about is called the zero exponent. Okay, so this is the zero exponent rule. This is going to tell us what we do when we see an exponent of 0. It says here, any number raised to the 0 power is equal to 1. So no matter what the base is, if the exponent is 0, that value is equal to 1. So this is fairly simple. I have 4 raised to the 0 power. That's going to equal 1. 16 raised to the 0 power. Why don't you pause and try to answer these next 3 questions, and let's see if we get the same answer. Okay, so hopefully you've paused it and you are understanding that the 0 power rule means whenever you have a base with the exponent of 0, it doesn't matter what the base is, the answer is going to be 1. So 16 to the 0 power is 1. 52 to the 0 power, 1. 6,324 to the 0 power, 1. Okay. If you were to do any problems involved with this, it would be helpful to expand out your exponent first. So in this example here, I have 3 to the 0 power plus 1. Why don't you pause that and try it and see what you think, how you think should be done. Okay, so if I am going to do 3 to the 0 power, I'm going to do that one, and I know that that's equal to 1. So I'm going to make that a 1. And then I'll bring down the plus sign, bring down the 1. 1 plus 1 is going to equal 2. Okay, so that means that 3 to the 0 power plus 1 equals 2. Okay, so that is your first exponent property that you've learned, and it is called the zero exponent rule. We're going to learn a few of these rules, about 5 of them. So please make sure that you are noting and taking note of the names of them so that when we talk about them in class, you know what I'm referring to. This is the zero exponent rule. It's when we have an exponent of 0. All right, the next one that we're going to learn in this video, it's going to be the last one we learn in this video. We're only learning those 2. It is the negative exponent rule. So this is referring to when we have a base, and let's say the base is 3, and my exponent is a negative number, right? Up until now, we've only seen them as positive numbers. So what do I do when I have a base with an exponent that is negative? That is the negative exponent rule. And if we look here at the definition, it says, please make sure you have this in your notebook, a negative exponent causes the number to be rewritten. So we're going to rewrite the number as the reciprocal. Reciprocal. Let's see if we remember what that is. Reciprocal of the original number, and the exponent becomes positive. Okay. So the reciprocal, so remember, if I have a fraction, I'm going to just do that here off to the side. If I have the fraction, let's say I have the fraction 2/5. Okay. The reciprocal of this fraction would be just flipping the positions of the number. So instead of 2/5, I'd write the 5 in the numerator and the 2 in the denominator. This is the reciprocal. Okay. So a reciprocal in this case, well, this 4 to the -6 that I have here, if I were to write this as a fraction, and you don't have to do this every time, I'm just doing it to show you. If I were to write this as a fraction, it would be in the numerator and 1 would be in the denominator. So what I would have to do is write it as a reciprocal. So I'm going to write 1 in the numerator, the 4 to the 6th in the denominator, but then it becomes positive. So you basically have to flip them, and then you make the exponent positive when you move its position, when you write it in the reciprocal. Okay. Let me try the one that I did over here on the side. So I would rewrite this. Currently, it is in the numerator position, and I know that because there's no denominator. There's a 1 there, invisible. So my reciprocal for this then would be to rewrite it with the 1 in the numerator and 3 in the denominator. And instead of a -2, because I'm moving it to the denominator, it now becomes a +2. Okay, and then I could expand that out as 3 squared, which was going to be equal to, remember this is 3 times 3, so that would be 1/9. Okay. All right, but for now, let's just rewrite them and leave it in exponential form in the denominator. Okay, so I'd like for you to try, pause the video, and why don't you try 7 to the -3 and 2 to the -4 and see if we get the same answer. So please pause it, try it yourself, and then come back and check to see if you've got it right. All right, so let's see here. We've got 7 to the -3. So I know this is in the numerator position because there's nothing under it. The denominator, when we have an integer and there's nothing written, it's an invisible one. We know it's there, but you don't have to write it, okay? So in order to rewrite this, to use the negative exponent rule, I do not want negative exponents. I'm going to rewrite this and put 7 to the +3 in the denominator. My numerator, the number on top, is going to be 1. So my new fraction will be 1 and 7 cubed. 1/7 cubed. Okay, which is 7 times 7 times 7. And for the last one here, I have 2 to the -4th. Because I see that it's a negative exponent, I'm going to use the negative exponent rule, which means you rewrite the fraction, moving the numerator up of 1 to the top, and now the denominator becomes 2 to the +4. When you write it in the denominator position, when you flip the position or write the reciprocal, you change the negative exponent to a positive exponent. Okay, so take a good look at those 4 examples, and you'll see that we have gotten rid of the negative exponents by rewriting the fraction as the reciprocal, and that turns the exponent to a positive number. Okay, so I have some problems that I'd like for you guys to do. I'm going to be checking your notebook for these 6 problems, A, B, C, D, E, and F, and we will go over them together. So these will either be the zero exponent rule or the negative exponent rule. I'd like to see you solve them, and then we'll do them together in class. I will be looking for these responses when I check homework notes. If you have any questions, please write them down so you can ask me when we're in class together. I'll see you next class.